We're going to start with the 2015 free response questions, and we're going to start with number 1. We've talked about before that there are 6 free response questions on the AP Calculus exam. The first 2 are graphing calculator required, and the last 4 are all non-calculator questions. So you have about 15 minutes per question for a total of 30 minutes on the first section and an hour on the second section, which means that you can pace your time out accordingly. Now, in some of these problems, when it's a lot of words, sometimes you can get confused or even carried away with how much information they're giving you. So up here, I've made a little key. As we read through this, I want you guys to circle all the variables, put a box around all the units, and underline important details. So it says, the rate. Remember, that's an important word. Every time we hear that word rate, we should kind of have our ears perk up that we're talking about a derivative. The rate at which rainwater flows into a drain pipe is modeled by the function r. Circle because it's a variable, where r of t, which is a variable, equals this function, 20 times sine of t squared over 35. Cubic feet per hour, that's units. Where t, that's a variable, is measured in hours, that's units. So far, all they're doing is giving information to us about the problem. And here's some important information as well. We're only looking over a certain time interval from 0 to 8 hours. It says the pipe is partially blocked, allowing water to drain out of the other end of the pipe at a rate modeled by a new variable. And again, we see that word rate. So keep in mind that these are derivatives, okay? These are rates. And then negative 0.04 t cubed plus 0.04 t squared plus 0.96 t cubic feet per hour, that's a unit. For again, that same time interval from 0 to 8. It says there are 30 cubic feet of water, so 30 cubic feet of water, all right, and we have some units there as well, 30 cubic feet of water in the pipe at time t equals 0. So far reading the directions, we've marked it up a lot because we have a lot of important information. So let's read it one more time all the way through. The rate at which rainwater flows into a drain pipe is modeled by the function r, where r of t equals that function. It's in cubic feet per hour. It's measured in hours. T is measured in hours. We're looking from 0 to 8 hours. The pipe also lets water out of the drain, which is modeled by this function in cubic feet per hour for 0 to 8 hours. And it's giving you some initial conditions. So there are 30 cubic feet of water in the pipe when the time starts at t equals 0. Now, you're not going to be able to answer every single part of these questions. You're only going to be able to answer part of them. So as we go through them, you can kind of read through the type of questions they're asking you, but a lot of them we're going to have to skip over for now since we're not fully aware of what we're getting ourselves into yet. So if you read the first one, it says, how many cubic feet of rainwater flow into the pipe during the 8-hour time interval? So if we're given rates, we're going to have to go backwards to figure out how many cubic feet flowed in. But we don't know that yet, so we're going to have to say that this one comes later. All right, we'll talk about that more second semester. That has to do with integrals. The second one, is the amount of water in the pipe increasing or decreasing at time t equals 3? And don't forget to give a reason, all right? If you don't give a reason with your answer, you are not going to get full credit for this. So, is the amount of water in the pipe increasing or decreasing? And we can actually figure this one out using the knowledge that we have. R of t is the rate at which water is flowing into the drain pipe. Notice that it says right here, into the drain pipe. D of t is the rate that it's flowing out of the drain pipe, out of the other end of the drain pipe. So we have water flowing into a drain pipe and water flowing out of a drain pipe. And it says, is the amount of water increasing or decreasing at time t equals 3? Well, here's all we have to do. We just need to figure out the rate at which it's going in and the rate at which it's going out and figure out which one is greater. And if the rate at which it's going in is greater, then the amount of water is increasing. If the rate at which the water is leaving the drain pipe is greater, then the amount of water in the pipe is decreasing. So all we have to do is figure out what R of 3 hours is, as well as what D of 3 hours is, and compare those two values. So we're going to get our graphing calculator, because again, we are not expected to figure this out by hand. And we're going to plug both of these functions into our graphing calculator. So I have in y equals 20 times sine of t squared, or in this case x squared, divided by 35. And again, don't forget to always make sure your calculator is in radians, not in degrees. And then I also want to know, that's the rate that it's flowing into the pipe. I want to know the rate it's flowing out of the pipe. So negative 0.04 t cubed, oops, not squared, t cubed plus 0.4t plus 0.96 t. And that one was t squared, wasn't it? Plus 0.96 t. All right, beautiful. So if I go over to my table, I'm going to go to table set, and I want it to ask me, because I want to tell it what to plug in. If I go over to my table, all right, I have y1 and y2. So currently my rate that the water is flowing in is going to be in y1. My rate that my water is flowing out is going to be in y2. So if I type in 3, here's what it tells me. It tells me that the rate that it's flowing in, R of 3, is equal to 5.086, and the rate that it's flowing out is equal to 5.4. All right, and this number is less than this number. 5.086 is less than 5.4, which means the rate that the water is flowing into the tank, or the pipe drain, I'm sorry, drain pipe, is less than the rate that it's flowing out. So more water is leaving than coming in, which means that the amount of water in the drain pipe is decreasing at t equals 3 hours because R of 3 is less than D of 3, meaning that the rate that it's flowing in is less than the rate that it's flowing out. So it's leaving quicker than it's coming in, period. So did we answer the question? It says, is the amount of water in the pipe increasing or decreasing? We said the amount of the water in the pipe is decreasing at t equals 3 hours. We gave a reason as well. It's because the rate that it's leaving is greater than the rate that it's entering. So on the AP exam, this one is worth a total of 2 points. And remember that each free response question is worth 9 points. So that just got you 2 of those 9 points. Now, if we read the rest of them, you might not know this, but I know this. We don't know how to do those pieces yet. At what time T is the amount of the water in a pipe at a minimum. We're going to get to that later. And then part D, it tells us more about the second semester, so we can't do those yet. So far we could earn 2 points on this first one.